Here we are, Pre-Calculus, Chapter 5, Section 8. This is the last section of this chapter, and we're going to take everything that we've learned and add a couple of new things to it, and we're going to calculate dot products of three-dimensional vectors and look at cross products as well, which is using matrices a little bit to help us be able to use vectors to solve problems. So here's our new vocabulary, cross product. I will define that as we go through and do this. Torque is one of the things you can calculate using a cross product. And a parallel pipehead is a geometric shape. We'll be talking about how to calculate area and volume. And the volume will be using the triple scalar product. Parallel pipehead is basically a parallelogram that's not laying on a sheet of paper. It's kind of floating around in 3 dimensions. A dot product is exactly like 2 dimensions, only it's 3. It's x times x, y times y, z times z, add them all together. If the dot product is 0, the 2 vectors in 3-dimensional space are orthogonal, or they meet at 90 degrees. So calculating a dot product, I'm going to go through the dot product pretty quickly because it's just doing the same thing, only you do it with z as well. So the dot product is -1 times 3, 6 times -1, -3 times -3. Added together, it's 0. That means those 2 vectors are orthogonal. And trying to plot 3-dimensional vectors to see if they're orthogonal is, in my view, kind of useless because they're difficult to plot. So let's do the same thing here. U dot V, same thing. It's -22, so they're not orthogonal. Now I'll give this one a shot. And I'm just going to say if it's -28, it can't be orthogonal. If it's -4, it can't be orthogonal. So you should get either -28 or -4. Go ahead and pause the video. Okay, I'll give you the answer in 3, 2, 1. Okay, -28. Now, finding the angle between 2 vectors, exactly the same way you found it with 2-dimensional vectors. Dot product divided by the magnitudes. Just when you find the dot product, you need to do x, y, and z. When you find the magnitude, you need to square x, y, and z. Add them together, find the square root. So, again, I recommend drawing out this step, going to here, and okay, so let's look at it right now. It's -43 over the square root of 26 times the square root of 72. You could simplify this before you get to plugging it into your calculator, or you could just plug that into your calculator. So let's look at how to do that. With our calculator, the first thing we're going to do, watch my keystrokes. -43. You can't do minus, you'll get an error. -43 divided by, and since we have 2 terms in the denominator, we need to do parentheses. We're going to do square root of 26, and to make sure we get out from under that radical, we need to hit the right arrow, times second square root 74, get out from under that radical, and close parentheses. Now, I didn't have to put times here because it will assume that if you don't put it in, and I hit enter. Now, that just gave me this term. Remember, we're supposed to find the inverse cosine. So now I'm just doing this to show you how you can use your calculator. If you do second inverse cosine, second answer, and answer is going to be whatever's right here on your calculator. Close parentheses, enter, 168.6 degrees. Now, let's do inverse cosine of -43 divided by, in parentheses, square root of 26, get out from under the radical, times square root of 74, get out from under the radical, close parentheses for the denominator, close parentheses for the inverse cosine argument, hit enter, and you get 168.6 degrees. So that's 2 different ways to use your calculators to enter the information So you don't have to enter and store and rewrite and worry about rounding errors and so forth. If you wait to your final answer and you plug everything in at one time, you will get the correct answer. And that's going to be required in calculus, that you do not round until the final answer. Now that we've looked at that, if you want to multiply 26 by 74 and get that huge number and then factor out a square root of 4 and get to square root of 481, you will get the same answer. But the point that I'm trying to make here is no need overburdening yourself simplifying a number that you can just plug into your calculator, and it's an intermediate step, so you don't need to rationalize it. And there you get the 168.6, which we just got with our calculator. There it is. And we're back. So now you get to try and find the angle. Go ahead and pause the video. You get the answer in 3, 2, 1. 102 degrees between those two vectors. Now, a cross product, this looks insane, doesn't it? All of this crazy stuff. So cross product is if you have vector A and B and you want to cross A with B. The good news is you can set this up in a matrix and it becomes really easy. So in this case, if it's U dot V, the first thing you do is you write ijk, and then you write the U vector, and then you write the V vector. Now we're going to break this 3 by 3 matrix into 3 2 by 2 matrices. And it looks complicated, but it's really not. What we're going to do is when we take I and put it behind this 2 by 2 matrix, we're taking these 4 terms and putting it into the 2 by 2 matrix. When you take J and you're putting it into this matrix, you take 6 and negative 1, put them down here, negative 2 and 2, put them down here, and then when you take K and put it over here, you guessed it, you take these 4 terms and you put them over here. So that's how you set up the matrix. Now, how do you solve the matrix? Here's how you solve the matrix. It's negative 1 times 2, this term times this term, minus this term times this term. 6 times 2 minus negative 2 times negative 1. 6 times negative 4 minus negative 1 times negative 1. So let's look at that. So negative 1 times 2 is negative 2. Negative 2 times negative 4 is 8, so it's minus 8. And you would do that for all 3 of them. And there are samples in your book that walk you through this as well. And then you come up with your cross product. The cross product of 2 vectors is another vector. And we're going to get into some application of this later on in this presentation. And then when you go from ijk, you just go back to writing things in component form. Now, what's interesting is the cross product is orthogonal to both U and V. So to prove that, we're going to do the cross product. And for a cross product, it doesn't matter if it's U cross V dot U or U dot U cross V. So you could do it either way. And you'll see, take the cross product and do the dot product with U, you get 0. Cross product dot V, and you get 0 again. And that's because both dot products are 0 because both vectors are orthogonal to the cross product. That's one of the definitions of a cross product, is it's orthogonal to both vectors. And you'll see where that comes into play when we do an example problem. Okay, now I'm going to let you find the cross product here. Go ahead and pause the video. I'll give you the answer in 3, 2, 1. Okay, there's your cross product. And again, you have to set up the 3 by 3 matrix, break it down into 3 2 by 2 matrices, do the multiplication, and you're off to the races. Okay, so here is an example problem. And if you have a wrench to tighten a nut, the wrench has a length, and you are applying a force to the end of that. And the concept of torque is how much foot-pounds force stuff torque is foot-pounds or newton meters or something like that. It's a force over a distance. And as I'm sure you all know, the longer the wrench, the less force it takes to move something. So we're going to look at how to use vectors to figure this out. So if you graph the wrench and then the force going down, and what we're going to do is put them in an X, Y, Z coordinate sort of system here and rewrite the vectors. We have to do that because remember, our cross product is going to be orthogonal to both vectors. So both vectors are in the XZ plane. So orthogonal to both of those, our torque vector should just have a Y component. So if we've done it right, we'll end up with just a Y component because it has to be orthogonal to the plane that contains XZ. So this is the wrench and this is the force. So the vector for the wrench is the distance cosine 35, the distance sine 35, and they simplified it here. And then the force vector 0, 0, negative 30. So 30 newtons and what is that, 0.4 meters, I think. So to set up the cross product, torque is the radius cross the force. You have to do it in this order, otherwise you're not going to end up with the right answer. So IJK, radius, and force. Set it up in a cross product. 0 times negative 30 is 0 minus 0. 0 minus 0. So I and K are 0. That's looking good because J is what we expected. And this side, you'll see a lot of zeros when you do torque problems, which is great. So it's really 0.33 times negative 30. And because we've rounded here and we've looked, it's 0.99. It's pretty close to 10. So you have a torque vector of negative. Oh, I forgot to mention you put a negative out in front of here. So it's plus I minus J plus K. Can't believe I forgot to mention that. So when you're setting up your three matrices, it's minus J. So minus a negative, you get a positive torque. And when you graph that positive torque, it comes straight out in the Y direction. And why is torque relevant? Well, you need to know the direction of the torque, and you need to know the magnitude of the torque. And I'm sure you can imagine if the force is at a different angle, the torque would be at a different angle. So if you're trying to take, and as an example, trying to take a nut off, if your force isn't directly up and down, if you're pushing a little bit left or right, that would mean your torque would not be perpendicular to the plane. And it's just from a mechanical viewpoint, if you want to be most efficient, your torque needs to be parallel to whatever it is you're trying to remove, a nut or something like that. If the further off parallel it is, the less effective you're going to be at removing that bolt. I'm trying not to go on a long lecture about torque and the fun of torque in 3 dimensions and how angles really matter. So I'll stop there. Okay, here's a guided practice for you. Apply everything that we just did in the last problem and look at your example in the book to apply it and try and figure this out. So pause the video. I'll give you the answer in 3, 2, 1. Okay, so that's B. Next, finding the area of a parallelogram if it has sides that are defined by vectors. And vectors have magnitude and direction, and you need both magnitude and direction to solve this. And to find the magnitude U cross V is going to give you a vector. Area is not in vector form. Area is a scalar. So you can't just use U cross V. And remember, positive, negative, positive. I didn't mention that earlier. I apologize. Okay, so this is the determinants, or this is your cross product. Now you have to find the magnitude of the cross product, which would be 12 squared plus 7 squared plus 32 squared. Take the square root of all of it. And the magnitude of the cross product gives you the area. So that's a parallelogram. And so that's just kind of floating out in 3 dimensions. And in our perfect world that God created, not everything is up, down, left, right. Some things are at weird angles, so you need to use weird math occasionally to solve these problems. So here is an example for you to work. Go ahead and pause the video. I'll give you the answer in 3, 2, 1. Okay, now a triple scalar product is if you have 3 vectors that represent 3 sides of a parallel pipehead, which is basically like the erasers that you see. It's a parallelogram in 3 dimensions, basically. It is the T dot U cross V, which rather than putting an IJK, you put T1, T2, T3 up here. And then when you set it up, rather than putting I, you put -3. Rather than putting J, you put 3. Rather than putting K, you put 2. So T dot U cross V, multiply it out, and you come up with a scalar. And the scalar is the volume of a parallel pipehead. I went through that one kind of fast. You might want to spend some time looking at that problem, because what do we have next? We have a guided problem and multiple choice here. So go ahead and pause the video and give you the answer in 3, 2, 1. And the answer is 2 for this one. And that wraps up Chapter 8 of Vectors. I hope you've enjoyed it as much as I have. Have a wonderful day.